Hello. Good morning. Okay. How about if I throw candy at you? Will you guys be more excited?
Yeah.
Yes. Okay. Hold on. Make it rain candy. There we go. So it's like it's a parade or something. Wait, yes, I got candy for everyone. So, yes. Who wants candy? There. Candy wants candy. 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 There we go. Candy. Yes, breakfast. Candy. Anyone else? Okay, good. You guys need some sugar.
Oh gosh, I forgot.
All right, so let's see. Solve a differential equation. Now, for these right here, these ones are special. Okay, an equation in the form of dy dx, f of x is an example of a differential equation. For any function y is equal to capital F of x, for which dy dx is equal to f of x, is a solution of the differential equation. The general solution of this equation, dy dx is equal to f of x, consists of all the antiderivatives of f. Now, the reason why it says it like that, all the antiderivatives, because there's a plus c. That plus c could be anything, right? So that is a general solution for that. And if I solve for whatever my c would be, that would be a particular solution. Okay, or a unique solution. So that is the particular solution for this right here. So the boundary condition, initial condition used in conjunction with the general solution to find the particular solution to a differential. So basically in Mathanese it says you're finding C also. Okay? Yeah. Yes.
Wait, since the derivative is the slope, what is the antiderivative? Is it also slope?
No, it's the function.
It's the function?
Yes.
Oh. Okay.
Yes, right? So, because originally we take a function, take the derivative, and that gives me the slope, right? Take the antiderivative of the slope is going to give me, okay, that's going to give me the function, right? So, if you think about it, specifically, now the derivative, it's some general solution for the slope. So I need to plug in an x value, and that will give me a slope anywhere on my function, right? Yes? Okay, so that's what helps us out there. But now when I have a condition for that, so I give you an x value, and then you plug in an x value into your derivative, you're going to find the slope at a point, right? Mm-hmm. Finding a slope at a point. But now we're going backwards off of that. So now when I do that, I'm going from the slope at a point to now getting the equation, the particular solution of a function at that point also. So, yes. Preach on, right? Anyway. Okay. Solve the differential equation dy dx equal x squared plus 2x plus 1 with the boundary condition when x is 3, then y is negative 1. Verify the solution. All right. So if that's dy dx and I take the antiderivative of the derivative, what should I write? Are we starting with the function notation? I'm not. So I'm not going to write a capital F. What would I write?
F prime.
No.
Normal F?
No. Just y. If the derivative is dy dx, right? And my original function was y, wouldn't it? So it should be y. So it's y is equal to, now remember the rules that I did yesterday, right? So if I'm taking the derivative, okay, and I'm going the antiderivative, I do what to the exponent? Add 1 to the exponent and then divide by that number. So I'm going to have x cubed over 3 plus, what am I plussing on this one? X squared over 2, right? But x, so this is going to be 2x squared over 2, which is just going to give me x squared. Very good. And then I have that plus 1, which is going to give me x, just plus x, right? So plus x, and then I do my plus c. This is commonly referred to as my general solution, right? The general solution. Now, to find the particular solution, I'm going to plug in my x and my y. Hey, look, if I plug in my x and my y, what's the only variable that's going to be left?
C.
Yeah, look at that. Wow. Not bad, right? Okay, so let's try that. So I'm going to say negative 1 is equal to, so 3 to the third power is going to be 27 divided by 3 is 9 plus 9 plus 3 plus c. So that's going to be 18, 21, right? 21. And then I'm going to subtract 21 from both sides, so I should get, so I get negative 22 is equal to c. So my particular solution to this function would be y equals x cubed over 3 plus x squared plus x minus 22. Come on, that was amazing right there. No applause or anything. There should be some like cheering on that belly. Man. Ooh. Man. Can I get a witness? All right. Are we okay on this? It's not too bad, right? Okay, let's keep going then. Okay, differential equations often involve higher order derivatives. For example, the second derivative is equal to 12x squared is an example of the second order differential equation. Okay, so now think about in physics. If it's the second derivative, that means it's the acceleration. So now I'm going to go from the acceleration, and if I'm doing the antiderivatives, I go acceleration, then that's going to give me the velocity, right? And I'm going to have a c value on the velocity, right? But when I do the antiderivative again, that's going to give me the position, but I'm also going to have a new c value, right? A new c value, and my original c value from the velocity is going to have an x onto it, isn't it? Yes. So they're not the same c values, so that's very important to understand. All right, the order of a differential equation is the order of the highest order derivative of y in pairing the equation. Okay? All right, let's do some math for that. Solve the differential equation for this with the boundary condition when x equals 0, y equals 1, and when x is 3, okay, and then y equals 8. Verify solution. So, that means that this is a second derivative. Okay, so we're going to find the initial condition c, then I'm going to find it again after I do my second antiderivative to get to my position. Okay, so that means that this right here, so if I'm taking the antiderivative of the second derivative in this notation, how would I notate that?
dy dx.
Yes, that's just going to be a dy dx. So dy dx is equal to
4x cubed
4x cubed plus c, right? I guarantee you the one issue that's going to haunt everyone in here is that plus c. Everyone. You know, it's like a math meme every year about forgetting plus c. I had one guy on a test, he actually went through and put plus c on every single answer first and then did the work. Just so he didn't forget the plus c. Alright, anyway. So, let's go ahead, find my, given this right here, x is 0, y is 1. What's c going to be?
1. Negative. Oh, wait, 1.
C is going to be positive 1, right? Because if I plug this in for my y, and that all goes away, c is 1. So, I know that dy dx is equal to 4x cubed plus 1. Now, I'm going to do the antiderivative again off of this. So, what's my notation going to look like then? Y. Very good. So, y equals x to the fourth plus x plus c. So now this is a new c value, isn't it? It's a new c value. It's not the same c as that I had last time because I have different conditions for this one too. So my new conditions on this is when x is 3, y is 8. So let's see, that's going to be 8 equals, let me see, x is 3, so that's 3 to the 4th, that's 81, plus 3 plus c.
Negative 76.
So what's the c?
C is negative 76. Oh no, because it's going to be 84 and then you subtract that from the 8, so then it's negative 76.
Negative 76? Okay. So, my function, y, is equal to x to the 4 plus x minus 76. Okay. Alright, you guys feel pretty good about this?
Mm-hmm.
Okay, good. Alright, let's see where we're at. Okay, guess what? There's the end. Okay, don't forget, like, share, and subscribe, hit that notification button, and, yeah.